this is a supplementary session, right. So, in this session we will see how to deploy multiple runs and do a statistical analysis, right. So, this TLBO function you might be remembering that we had made this TLBO function, right. So, right now it is a function file, right. So, we need to only provide the detail of the problem, right. So, this has to be a function handle, the lower bounds of the problem, the upper bound, the number of population, the population size and the number of iterations that we want to work with, right. So, this is the script file, again this we have discussed, right. So, here what we are doing is we are defining LB UB problem, right. So, let us just work with the sphere new function. So, we are setting the population size to be 10 and the number of iterations to be 50, right. So, here we are calling the TLBO function and we are passing this details, right, and what we will be getting back is the best solution, the fitness corresponding to the best solution, right. In each iteration what was the best fitness, right, the final population, right, and the final fitness function value, right. So, remember this is different, this best fit iter is different from F. F is the fitness function value corresponding to each population member, right. So, this is only of the last generation, P comma F is of the last iteration, whereas best fit iter is the best fitness function value in every iteration. Best sol again is the set of decision variable at the end of the algorithm, the best solution that we have discovered, right. So, this is decision variable and this is objective function, right. So, best sol if you see it will have, in this case we have a 4 variable problem. So, it will be having 1 row 4 column, this will be a scalar 1 cross 1, we are having 50 iterations and remember we also have the initial evaluation of 50. So, this will be a vector of 51 rows and 1 column, right. We are working with a population size of 10. So, at the end of the iteration this will be 10 cross 4, P will be 10 cross 4 because we are working with a population size of 10 and the number of decision variable is 4, right. So, this will be 10 cross 4 and F will be a 10 cross 1 vector. Let me execute this, right. So, if we execute this, let us do a whos. So, whos is going to show all the variables and their size, right. So, best sol it is supposed to be a 1 cross 4, right. So, this is the best solution at the end of 50 iteration, this is the best solution that TLBO has discovered. This is the fitness function value corresponding to this solution, right. Best fit iter if we see it has 51 rows and 1 column, right. So, if we plot this, plot best fit iter, right. Right. So, here I had used uppercase E, right. So, that was the problem. Okay. So, this is the convergence curve, right. The x axis is iteration, the y axis is the best functional value obtained at the end of that iteration. So, P if you see it will be a 10 cross 4 because 10 rows corresponding to each population member and 4 columns. Similarly, F is 10 cross 1, 10 rows and 1 column. Fitness function value for one solution is a scalar value. So, we have 10 solutions over here. So, this will be 10 cross 1, right. So, now if we execute this, so now we have a value of fitness function is 7.95, right. So, if we again execute this, I get a different fitness function value 4.10, 4.56, 2.2, 1.24, 1.15. So, this is happening because the algorithm is stochastic. Remember this algorithm, the very starting we are saying that randomly initialize the population, right. So, every time we run it is going to randomly initialize the population, right, and in multiple places we are using this random selection, right. Here again we are using generating random numbers, here we are randomly choosing the TF to be 1 or 2. So, every time we execute it we are going to get a different solution. So, in this case the question is how do we reproduce the results, right. So, what we can do is we can make use of this function RNG in MATLAB, right, help RNG, right, to so it will help us to control the random number that is generated, right. So, what the syntax of RNG that we will be using is RNG SD comma generator, right. So, generator can be any of these 9 values, right. So, they have 9 different algorithms to generate random numbers. MATLAB generates pseudo random number, right, using one of these algorithms, right, and SD is a integer value, right. So, if we have over here RNG 1 comma let us say twister, right, and if we save this and if we execute it, right, every time we will get the same solution, right, because every time before executing this function we are resetting the random number generator, right. So, so in this way we will be able to reproduce the results, right. So, now the question is, if we are able to reproduce the results, why should I have it as just 1, why not 2, right. So, if I change that, the value would change, right. So, now we have the fitness function to be 2.47 into 10 power minus 10, right. So, since these algorithms are stochastic, we are supposed to run it multiple times, right. So, we run multiple times and then we do a statistical analysis, right. In this function we are going to implement the multiple runs, right. So, over here we have defined the number of runs to be 10, right. So, then we will define some of the variables which we will be using, right. So, the first variable that we would require is best solve. So, every time we run it, we will get a one row and as many columns as the number of decision variables, right. So, we are defining best solve with with the values of NaN, right, and that matrix will have 10 rows or the number of runs n runs comma 4 columns in this case, right, because we have a 4 variable problem, right. So, this length of LB will give us 4 and this n runs is 10, right. So, this is just initialization. So, every time we run this problem we will store the best solution over here, right, and we will save the fitness function in best fitness, right. So, best fitness, if you remember, it was a scalar value, it is a scalar value for one run. So, for 10 runs it is going to be a column vector, right. So, we have 10 rows and one column. For every run we will get 51 column because there are 50 iteration and the first initial population will also have the best fitness function value, right. So, this will be 51. So, that is why we are doing t plus 1, number of iterations plus 1, and for every run we will have a convergence curve, right. So, that is why we have this best fit iter, right. So, best fit iter, if you see, now we have 51 columns and the number of rows would be 10, right. So, if we do whos over here, so here you will be able to see 10 rows 51 columns. So, every time the first time when we run, the convergence curve will be stored in the first row, right, all the 51 values will be saved in the first row. The second time when we run it, all the 51 columns will have the convergence curve of the second run, right. So, that is why that is how we have initialized these variables, right. So, this whos is not required over here. So, now we are going into the algorithm. Remember, every time I need to run with a different seed. So, that is why we are doing RNG of I comma twister. So, the algorithm remains the same, every time we are changing the seed of the algorithm, right. So, every time we expect to have a different set of random numbers used, right. So, step, right. So, let me, if I do step in, it is going to go into TLBO, right. I do not want to go into TLBO because we know what is going to happen in that function, right. So, let me just give a step, right, and again a step. So, it has completed the first run. So, after completion of the first run, if you see the best solution, the first row has been populated. So, this is the best solution obtained by TLBO in the first run, right, and this is its fitness function, right, and this is the convergence curve, right. So, in the 0th iteration, the fitness function value was 8.8053 into 10 power 3, right. So, this has 51 columns, right. So, then we are plotting it, right. So, step. So, this is the plot of the first run, right. So, the x axis is again iteration, the y axis is the best fitness function value, and this shows the convergence of the first run, right. So, similarly we can proceed for the second run, right. So, the second run we want to plot on the same plot, that is why we have hold on, right. I want the values of the first one to remain and I want to plot the values of the second run, right. So, if we do this step, so now it is I is equal to 2, right. So, when this line is executed, the 22nd line is executed, it will reset the random number generator with a seed of 2. Right. So, again if we do step, right. So, now if you see, so second time when we executed the algorithm, this is the set of decision variables at the end of 50 iterations. This is the fitness function, right, 0.2148 into 10 power minus 9, right, and this is the values for the convergence curve, right. And if we plot this, so now we will see we will have two colors, right. So, previously we had this blue color, right. So, now we have another curve over here. Right. So, this now we can execute for 10 times, right. So, every time a row would get populated, right, and the figure will also have one more curve. So, as you see, for every run we get a curve over here, right. So, right now we have completed 8 runs, so we are in the 8th run, right. So, it has completed all the 10 runs, right. So, at the end of 10 runs, this is what we have. If we see the best solution, right, and the best fitness. So, for every time the fitness function value that was obtained at the end of 50 iterations is given over here, right. So, this is the result of the 10 runs, right. So, now what we can do is, if you look into this best fit iter, the rows indicate the run, the column indicates the fitness function value. So, we can find out the mean, right. So, we will get, so we can plot the mean over here, right. So, this is the mean. So, remember we had 51 convergence curves, right. So, at the end of first iteration, right, the average of all the 10 runs. So, for example, let us say best fit iter, right. So, I am looking for the all the runs, the first column, right. So, the first column will correspond to the 0th iteration, right, and the second column will correspond to the first iteration at the end of first iteration. So, at the end of first iteration, this is what we had, the mean of that column is this particular point, right. So, at the end of first iteration, what is the average fitness function value obtained across all the 10 runs, right. So, this is again best fitness function value, average of the 10 runs, the y axis is average of the 10 runs, whereas the x axis is iteration, right. So, this is how we can have a single convergence curve which reflects all the 10 runs that we have executed. So, we can add the x label and y label. So, x label is iteration and y label is, right, so average of best fitness function value. So, this is the iteration and this is average of the best fitness function value. At the end of first iteration, we had 10 values, right, corresponding to each run, right. So, the average of that is plotted over here. Now that we have plotted the mean convergence curve, right. So, we will now we can also do a statistical analysis of this best fitness, right. So, this best fitness has 10 values. So, now we have this best fitness function value, right. So, now we can perform a statistical analysis of this, right, as to what was the best value we obtained in the 10 runs, what is the worst value we obtained in the 10 runs, what is the mean of the 10 runs, so, what is the standard deviation among the 10 runs, right. So, that is what is done in this file, right. So, here if you see, we have discussed all these 3, right. So, similarly whatever we have discussed previously, all this we have discussed previously. So, we are defining a variable called as stat, right. It is going to have 5 values, right. The first value is going to be the best of the fitness. So, we have this 10 runs, right. What is the best among this run, right. So, that is what will be best fitness, right. The worst is the maximum value. So, max of best fitness is going to be the second column, right. Mean of the best fitness is going to be the third column of stat. Median of best fitness is going to be the fourth column of the variable stat, and the fifth column of the variable stat is going to be the standard deviation. So, we have assigned that the first value is minimum or the best, the second value is the maximum among the 10 runs or the worst, mean, median and standard deviation, right. So, all these 5 are inbuilt functions, right. So, to find out the minimum value, maximum value, the mean value, the median value and the standard deviation, right. So, if we now execute this, right. So, this is the mean fitness curve which you know, this is the convergence curve of each run, right. So, here if we say stat, right. So, the 10 times we ran this problem, the Rastringen function problem, right. The best that we could get was 1.3916, the worst that we got was in the 10 runs 5.7834, right. The average of the 10 runs is 3.5686, the median of the 10 runs is 3.0193 and the fitness and the standard deviation is 1.4969, right. So, this is nothing but the statistical analysis of this vector best fitness, right. So, here if we see the best value is 1.396, the worst value is the first run 5.7834, the mean, if you calculate the mean of this, it will work out to be 3.5687, the median is 3.1093 and the standard deviation is 1.496. So, if we are interested in the decision variable corresponding to this 1.3916, let us say we are interested what is the set of decision variable that will give us this 1.3916. So, over here we can modify this as, in addition to the value we can also get the location, right. So, IND will be the location. So, in this case it will return 3, 4, 5 because it is located in the fifth one, and best solution we have saved in over here best sol, right. So, best sol, right. So, we are interested in the this row and all the columns, right. So, this will give us the best solution, right. So, this is the stat, right. So, the best fitness function value is 1.3916, right. So, if we see best fitness, it is 1.3916 and the corresponding solution is this one, or we can look at best sol. So, best sol, remember it will be a 10 cross 4 matrix, right. So, the fifth one, right. So, the fifth one is 1, 2, 3, 4, fifth one is this one. So, which is what was given over here. So, that is how we extracted the best solution. So, this is how we can perform statistical analysis. We take an algorithm, right, run it multiple times on the same problem, and then we find out among the number of runs which we have executed, what is the best value, what is the worst value, what is the mean, standard deviation and median. That is the end of this session.